So today we will start the first exercises or the first problem in the book of Shreve and Karatzas, Brownian motion and stochastic calculus. This exercise is about say that if y is a modification of x, are two processes and one is modification of the other, then if we suppose both are having a right continuous simple path, so they are right continuous almost surely, then we can pass to indistinguishability. So first we know that modification, one is modification of other, is weaker than indistinguishability, that they are indistinguishable, in the sense that if we recall the definition that what means what means an x is a modification of y, or y is modification of x. Of y if for every t positive we have an empty set that depends on t of t. Okay, it's an empty negligible t with, it means it's a set with measure 0, negligible, such that xt or xt of omega equal yt. Our two processes, stochastic processes, are equal. Okay, almost surely means, excuse me, for all omega in omega minus this empty set nt. So for every t we have one empty set, a special empty set, okay, which is such that we have this relation. But for indistinguishable, x and y are indistinguishable, means that we have a set n negligible such that doesn't depend of t, and for all the t's, such that we have xt of omega equal yt of omega for all the t's. Okay, this n negligible set of the independent of t is for all the t's. We have the same set for all omega, no omega minus this negligible, almost surely. You see? So the problem here, that here for every t we have one empty set, a special empty set. Here we have for all the t. So one will try to take n is the union of all n t in R plus, okay, t positive. The problem that this union is not anymore negligible, cannot anymore negligible. For instance, if you take this interval, for instance, you take a random variable that is uniformly distributed, you know that this set in any, if I take a point here TE, 1 point for instance from this interval, for instance let's take it 1 2. What is the probability of u equal 1 point TE is 0. But if we take union of all these TE in 0 1, probability of u equal, or it's in the union of all TE in this interval 0 1, but this is only, it's just, and probability that you take a value in 0 1, it's all the probability 1. Yeah, so you can see the difference. We cannot take union and still have a negligible, hope to have a negligible set. But what we will do, instead of taking here Q R, if we take a countable union, this still correct. So instead of working with R plus, we will work with space Q plus in these exercises, which is countable, and union of countable union of negligible set is negligible. Okay, we don't have this problem if the union it's in account, it's countable. Yeah, so here we will use the, for here we need the right, will help us the right continuity, because what means right continuous? A process is its right continuous, or any function is right continuous if this limit. Okay, what means right continuous? It's something like this, a function is right continuous, or a part of a stochastic process is right continuous if we have something like this. Yeah, so it means that if we converge from the right side to the point, we have the image of the function. Okay, we have, but if we come from the right side, this is right continuous. We have the same for y. They are both. Yeah, but we have almost surely right continuous. So here we have, of course I am speaking here about xt of omega is function of two variables, t and omega. For all omega, because it's almost surely, it means all the omega in our state space, sample space, minus negligible set that we will call it here omega x, and here the same omega y. Okay, and here the trick that instead of converging here in R in a manner, we can just take converge in a sequence that is in Q of a rational number. So this limit, we can choose it as the limit of a certain Tn converge T0. Okay, we choose just point Tn that there are in Q, Q plus. Okay, Q plus, it's Q and intersection enter 0 plus infinity. Okay, of x Tn of omega. Okay, of course coming from the top. Okay, Tn will be bigger than, so here instead of this I can we can converge like this. Okay, and we have the same thing. We can choose the same sequence or different seconds, doesn't matter here. Okay. So now what we have that x is modification of y. It means that for every t, as I said, for every t positive, we have x. Okay, sorry. So where we've been, we have here that the x and y are modification of each other. It means that for every t, we have a certain negligible set in t, okay, such that xt and yt are almost surely equal for all omega minus this negligible set. Okay, the same. And because for every t, so we will take for every tn, for every n, or for every tn positive, we have n tn, that x of tn omega equal y of tn omega no, minus tn. So here if we take, this is all the tn in q, yeah, tn are in q. If we take n union of all n tn avec tn in q plus, okay, this is negligible. And we don't forget also that we have some right continuity only almost surely, so we should take also this omega x and omega y. So if we take this set union omega x union omega y, this set, if we call it n, this it's with measure 0, so it's negligible. And we have the following things for every tn. So what we have that x of tn omega equal of y of tn omega for all tn, okay, q plus, for all omega minus that big set n, which is also negligible. Okay, and now we pass to the limit. When we pass to the limit here, we use the right continuity. Yeah, we can pass to the limit using this limit when t over in any t0 on when tn converges to t0 or any t. So if we pass to the limit here, we'll have limit of x tn omega equal limit also of y tn omega for all tn for all omega, the same here when n tends vers infinity. Okay, and this is xt0, or in general xt equal yt omega for all t. Now we pass to the limit for all t dans r plus for all omega minus this set, and this means that x and y are indistinguishable. Okay, and we have an example where if when we can see example of two processes that there are indistinguishable, but there are not modification of each other, but they are not indistinguishable. Of course, they will not be right continue. So I give you the example. If we take u is the distributed uniform random variable, okay, on 0 1, okay, and if we take two processes, x of t omega equals 0, all the time it's 0, and y of t omega equal 1 if the first variable t is if t equal u, if t equal the value that take this uniform variable equal 0 if t different of u. Alors, these two variables, you can see that there are modification of each other. Why? Because for every t fixed, if we fix, what is the probability que xt différent de of yt? Okay. For the negligible set, what is the probability that these two are different? Okay. This probability is only probability when there are different. Only if yt take 1, it means if u equal t, and the random variable, continuous random variable, taking one special value is always 0. Okay, a continuous variable, the probability that it takes just one value is 0. Okay, so and here, and if so, this means that, okay, p of xt equal yt, it's equal 1 for every t. We have that these are equal except for a negligible set, but this set depend of nt, so this means that x and y are modification of each other. But let's see that they are not indistinguishable, because if we take probability of xt equal yt for all t's, for all the t's to be these two equal, this you can write it in this form. What is this probability? They can never be equal all the time. It's all the time we will have a value different, which is 1, and so this is 1. Yeah, sorry, we can take here this is 0, so, or I can take here a different. Okay, they are not different for all the t, you see, as we can see. So there are all the time, for all the t there are different. So, and this is not it means that they are not indistinguishable. And you can see that here we have this y is not continuous because it's taking 0, then suddenly she is in some random time, positive random time, it's jumping to 1, and after it's coming back to 0. So it's making something like this, jumping to 1, and then it's not continuous at all, and it's why we don't have, it didn't give us the right the indistinguishability. Okay, thank you.